Okay, YouTube streams up. Let's go. But Spectre got the actual first like redeem. You shamed you did in the last few streams. Here's a person just said thanks. Yeah, to be fair, Spectre, there was daylight savings time here, so it's a pretty like nice excuse. Oh god, this is gonna be one of those days where I just can't find any questions on Reddit. Is it like when like the very first thread already has like 6 comments on it, so you know things are bad. Pretty busy. Oh yeah, fair enough. Okay, you know who, like the next time you beat Spectre, you need to really annoy him and actually get that first redeem with the channel points. Like it's in that little like menu with the with the coffee beans, right next to like the chat button. If you get that before Spectre does, like you're gonna be in business. You know, nerd people can be busy. Jeez, you savage. JK, don't hate me. No, that was good. I think it's the first time I've seen a burn from you, hoo hoo. I like it. Yep. What a nerd, Spectre. You should start streaming about math. That'll make you not seem like a nerd. Oh, what is this? Spiral of consecutive numbers is created as shown starting with 1. The pattern of spirals continue. In which range of all the numbers? What? This is some weird stuff. Like, what do they mean, what arrangement? Like, if they'll be on a corner? Or all on a side? Or what? You know, it's too bad. Alright, no worries, Spectre. Thanks for trying. We need someone to stream quantum physics as well. Want to do it? If I knew quantum physics, then sure. I mean, I've said this about a lot of things, but honestly, I have half a mind to restudy physics. I feel like it'd be kind of fun to it's like when I took calculus-based physics, it was before I took a differential equations class or multivariable calc, and I feel like physics would be a lot more interesting with those 2 things in your toolbox. So I think it'd be kind of fun to honestly go back and try to relearn some physics, but that'd be like, probably won't actually do it, and then be like years away from getting to quantum physics. Yeah, Jed, this one, I don't know. Like, I'm trying to figure it out. Like, it shouldn't be that bad. You took my physics without even having courses on derivatives yet? Oh, dude, you calculus-based physics without having taken calculus? I'm surprised they would let you do that. Now, there is, like, algebra-based physics, which is normal to take, but I assume you mean, like, calculus-based. That sounds terrible. It was already hard enough. You have an idea? Yeah, I assume you need to make some kind of like progression. Like it's like I guess 1 wide, 2 wide, 3 wide, 3 wide, 4 wide, 4 wide. Actually, no, okay. 2, 2, 3, 3, 4, 4, 5, 5, presumably 6, 6. Or yeah, we start for I started from 2, you start from 1, but same thing. How do you figure out don't count the center? Literally, they're in the same semester, you're just doing limits in calculus. Oh no! Yeah, that's terrible. Oh, okay, yeah, I was counting the literal amount of numbers, but yeah, I mean, I guess you can count the arrows too. That might be better. Can we say something about like the like depending on what multiple of number determines where you are on the square, maybe? I feel like it wouldn't be true though. Oh, it's a competition problem. Okay, that explains a lot. I'm still interested to see if we can figure this out, but I was just curious what like grade this person was in. Forgot the pattern 1, 7, 21. Maybe we could have changed it to fixed curriculum course. Yeah, exactly. Oh no, so I'm not doing competition or anything, but it's just this random thread on Reddit that says math contest, algebra, and geometry. So I assume this is some kind of a competition level problem, even though it. I mean, I'm sure it's like equivalent to some number theory thing. Hey Dan, up, down. You have to cheat code. If you figure out this pattern, you get invincibility in real life. The 7 watch streak, Jed. Thank you. Got those 450 coffee beans. Hey, SPQ. Yeah, okay, so can we say anything about the corners? That's an interesting thought. Like 1, 7, 21, 1, 3, 13. Oh god, 1, 10 something, 1, 5. What is the pattern there? Like, it's almost always odd numbers on the corner except for 10. Okay, so this goes from 1 to 7, which is a difference of 6. That goes from 7 to 20, which is a difference of 14. So 6 to 14. That goes 2 to 10. You're right. I could just draw the entire sequence to 627. 4 to 12? I'm not seeing an easy pattern. The classic competition thing, Jed, where they use the year as part of the question. Well, maybe this question was made in the year 625. We don't know. 43? How do you know that? It's a very old company. Yeah, exactly, Stooky. Hey, Bode. 25 plus 5 plus 6 plus 6? Well, we're 21. Oh! So yeah, okay, wait. So well, part of cycle 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 5, 5, 5, 5. Sorry, 6, 6. So okay, I get your rationale of 21 plus 5 plus 5 plus 6 plus 6. Is there some kind of weird thing where you do like a +1 just for fun because that makes it work? That's what I'm worried about. Like 1, 2, 3, 4, 5. Like, are we double counting a corner, maybe? We go, no, it's gonna be 5. If you count the arrows, you're not double counting, I guess. And we're counting the arrows. Oh yeah, Plazon. It's been a lot of fun to have that redeemed. Since you're not here that often, if you want to request something that, like, because no one in chat who has a question, so I might be persuaded to do some charity artwork. SPQ is saying we want 3 plus 2 times 3 plus plus n is less than 625. Did manually figure it out from there. Should be on the bottom, go from right to left. How do you get that that formula, SPQ? Is that it's like even go up, then right, odd to go down, then left for greater than or equal to 3. Even go up. What color whiteboard markers? Black, blue, red, green, and orange. One up, 2 right, down 3. You go n up, n right, n plus 1 down. Sides of even length n. One plus 2. Oh, I see where you get that 2 plus. Okay. Or like what? Why we're multiplying by 2? Sides of even length. Yeah, so that formula would only get you the even parts of the spiral, which is hopefully enough. I guess the word arrangement is still vague to me. Find max. 1 plus 2. It's like, do we care if they're just all in a row or if they're like on a corner, I guess is the question. Like that's the only thing I think of what I mean by arrangement. I think I understand what you're getting at, SPQ. I don't think I come up with that for myself, but I think I can follow it now that you say it. And so, in Jed, are you saying basically the same thing, it seems? Or you verified that against the things that you calculated there? Okay. Yeah, I guess it is basically some kind of sum of numbers thing, which is really a stupid thing to say because that was established a long time ago. So it would be, according to SPQ, on the side length involving 24. Can we determine where on that side length it happens? I guess is the next question. Because I'm interpreting arrangement to mean the answer they want is either they're all in a row or they're split on a corner. But I guess we don't really know that, do we? If that's what they mean. We determine in a vacuum where the 24th, or where the side length of 24 starts with what number. You would plug n equals 24 into the formula SPQ. Wouldn't that get you 625? I equals, oops, I equals, I is equal to, 24. Maybe we start at I equals 3. I. $597. So I'm assuming that 597 is a corner. And 625 is more than 24 away. So this is on the second side length of 24? Because they're each... No, wait. If we're doing 2 times that, I think I'm already on the second side length. So should this actually be on the side length of 25? Okay, yes. Because 597... Oh, and you did write the plus 25 earlier, didn't you? So they'd be on the second... Wow, okay, that's crazy. So they would be all in a row on the second side length of 25, because the thing I had before... Was that actually the end of the 24th side length, which was the beginning of the 25th? God, it's so hard to interpret. I think that's what it is, though. And so if we're doing plus 25, that means we're at the start of the second side length of 25. Oh my god. It's crazy. Wait. Is it 1 plus 2 or is it 1 plus 1 and then 2? Then shouldn't it be 1 plus 1? Or why is it 1 plus 2 for the start? Because it's just 1 arrow, and then our pattern starts with... Actually, well, couldn't this be... No, it's just a pair of 1s, a pair of 2s, a pair of 3s. Wait, no, it doesn't. Wait, oh. 1, 1, 1, 2, 2, a single 3, and then we get pairs. Is that cause for concern? Is this just like a one-off thing, or does this exception continue on the left side? Do I actually need to draw this out? I feel like that's what I would have to do to feel more confident now. Counting numbers on the side, not the arrows. Oh, okay. 1, 1. I don't know what's simpler now. This feels right. You have 627 in the upper right corner of the 13th loop. That's not what we have. I don't know what 13th loop is, but we got it so 627 would be on the second side length 25. Yeah, I think they'd be just like somewhere all in the middle in that length of 25. At 601 in the lower left corner. Kizzle, so thank you for the follow. Probably saying that wrong. Yeah, I feel like this would be a good one to just have a computer do for you, to be honest. I would put my mug away because I'm out of tea, and I might actually just draw another loop here. Because I feel like I'm a little concerned that I don't actually understand the pattern here. Like, I think I understand the pattern, but I'm concerned that I don't actually understand it. Okay, where should the problem go? We'll put you down there. Okay. So, I just want to do another like loop around from what they gave because I'm a little concerned about that like one side length of 3. So 1, 2, 3, 4, 5, 6, 7, 8. What the heck? 9. That's a weird arrow. Please don't make fun of it though. I'm very insecure about my arrow drawing abilities. $19, $20, $21, $22, $23, $24, $25, $26, $27, $28, $29, $30. This is a counting shin, guys. This is the type of math that I'm best like suited to. Don't ask me any more calculus questions. Just like what number comes after 5? That type of question I can handle. I hope. You can watch me make a mistake on this. 37, 38, 39, 40, 41, 42, 43, which is what Jed said for that corner. And I'm just gonna do that last length up there. And then I'll do my ... Wait, I did 46 twice. Okay, no more counting questions either. Just don't ask me questions in general, I guess. Just let me ramble like a crazy person. Okay, ... Do the numbers a different color? Oh, too late. Calculates accordance with a given number, assuming 1 is placed at 0, 0. Oh, I guess that's true. Hey, Saba, it's 46 plus 1, Jed. God damn it. 47. And hey, Saba, I do whenever I see a J in someone's Twitch username, I don't know if it's like a normal J like I'm used to, if it's a J like a Spanish J, or if it's like a J like how would you describe it? When you pronounce the J like a Y, like in like Russian and like Polish and like those like type of languages. But whatever your name is, we'll welcome in. Okay, so I did this. Why did I do this? Because I was concerned about that side there, right? So I'm going to count the numbers, I guess, he was saying, yes. So that's just, we're going to count that as 1. That's 2 for those two. 3, 3, 4, 4. Are we, oh, wait. This is double counting, isn't it? Like, if that's 1 and that's 2, shouldn't that be 2? But then that messes up. No. We should just do. We should just double count and be okay with that, maybe. Because that's the length of the side. Okay, that's why you just count the arrows instead. That might. Yeah. Okay, let's try counting the arrows. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, I hope? 7. Okay. So at least with the arrows, there's no like exception in the patterns. It could be, so maybe let's try to make a formula. Well, just I lost a thread. I'm gonna be honest. I don't know how to do this problem. I had an idea. It doesn't work though. See your Wolfram? Okay. So what's this? How are we interpreting n? I assume that's having different values for n up to 12. Isn't this just a different looking Gaussian sum? Oh, this goes along the corners. Oh. How do we... Okay, so experimentally, this definitely seems to work. So actually, well, okay, wait. N equals 2. Gets you 21, which is the second, it's the second lower left corner number. N equals 1, I assume we'll get a 7. Okay, and that's what you're saying, Jed. Okay. And then you keep on plugging in larger... This is hard to explain. Yes, Jed, this formula seems to work. I just need to. I can explain it where it comes from to someone else though.
Hello.
Oh, hey, I'm not even on push to talk. Okay, that works.
So yeah, so we've established that if you're counting the arrows, the first loop you're going to go up 1 over 1, down 2, left 2. Then the next loop you're going to go up 3, right 3, down 4, left 4. So we're always counting in pairs, right? We go 1 1 2 2, 3 3 4 4, which is why we have the 2n as the top of the sum, right? I equals 1 to 2n. The 2 times is because we're counting each number twice. So we're counting 1 1, 2 2, so that's going to be 1 plus 2 times 2, right? And then we do 3 and 4, we're going to do 1 plus 2 plus 3 plus 4 twice, which gets us that 20. And then you add the 1, which is the center one, because we're just not starting, because we have to include that 1 there, and that puts us at the 21 of the low. Does that make any sense?
I feel like we double counted with this two n and 2. So, but
The
we
reason
obviously aren't.
is
But
because
why?
if I just did n, you'd be all toggling between the bottom left and the top right, bottom left, top right, bottom left, top right. By
Also,
doubling the n,
an
I'm
odd
always getting that
n,
bottom left.
like if n is odd, it will get you the upper right. That's what
Correct.
you're saying. Okay. And this is just our
If
way of
if not
forcing
if
it to
n were
be.
odd, if 2n were odd.
Well,
So
wait,
if you go
2n is
half a
never
loop,
odd.
if you go half a loop, so if you put n equals 1.5, then you should get the top right corner of the. So it's you a full loop plus the half of the next loop.
Okay, it does. Yeah, 13 is the first
So
upper right.
it's how many loops are we doing? Starting at 1, how many loops to get back to the bottom left, and then another loop, and then another loop. And the way we're doing that is the sum of I to n, or I from 1 to n, right? That gets us halfway around, gets us half of it. And then we have to double it because we're doing each length twice. We go up 1, right 1, so we have to count it twice. Down 2, left 2, we count it twice. And so by putting 12 in there, you figure, okay, if I do 12 loops, what's my bottom left number then going to be? And you get 601. And your next part is going to go up 13, and then right 13, down 14, left 14. And so if you go up 13, right 13, that's 26 more than the 601. You're at 627, which is one of the points you're looking for. Does it make any sense at all?
I'm like halfway there. So I think this
So
2n part, it's unnecessary, but it's not bad. It's not wrong.
it makes sure that you're always looking at the bottom left corner. If you just did n, you'd have to know, okay, if n is even, it's the bottom left. If it's odd, it's the top right, and you'd have to try to figure that out. So yeah, if you did n is 12.5, then you end up with that 627, correct?
Sorry, n is what?
12.5.
12.5. Let's see. 651. Which
Is that one of our, no, 657 is
625, 626, 627.
Okay, so I was off. What if you're on 12?
Well, I mean,
I can't add.
It's something we know what happens between the 12th bottom left corner and the, I guess.
And the 13th is basically adding another 13 up the left side, 13 across the top, 14 down, and 14 on the bottom. So if you put 13 in there, or excuse me, no, that's not right. If you're on your 12th loop, then that means you're actually going 6 up. No, I'm confusing myself now. 12th loop. So the first loop starts with 1 going up. The second loop starts with 3 going up. So the 12th loop would actually start with 25 going up.
Okay.
So 626 would be the top left corner. And then you go 25 to the right, and that would give you 651.
Oh, wait, how do you know what 626 is on the upper left corner again?
Because you're going to go from 601, and you're going to go up. 25, because your next step is going to be your
How do you know it's
your side length.
25?
It's the 12 times. So we just finished 12th loop, right? Or the 12th, yeah, the 12th loop. And so the bottom is actually going to be of length 24 because we're doing 2n, right?
I would say it's okay. Yeah. So in that case, I just want to get rid of the 2n entirely and just only have this as my
Sure.
yeah.
But that now you have to figure. Okay, so 12 is, so if you do 24, you're in the bottom. You're the bottom left.
Yes.
If you're 25, you're in the top right.
And so, well, 24 and a half wouldn't be defined for summation. Hold on.
No, it wouldn't.
Wolfram Alpha does something, but I don't know how to interpret that.
Well, yeah, I don't know how to.
I was curious to see what it would do.
So N25 should be 651 as well, right? Or
651, right?
Yeah, whatever you had.
So yeah, we know that that's the upper right corner, and that. Wait, so if it's 25, wait, where do the pairs? The pairs are right and bottom or
the reason
left
we're doing
and
times
upper?
2 is because you're always doing 1 1, 2 2, 3 3, 4 4. So we have to count that sum twice every iteration, right? That's why the 2 times is there. And then the 1 is to make sure we include that central 1 because we didn't start at 0. We started at 1.
So that's gonna be a different question. Why is the 1 getting summed every time though?
It isn't. The summation is only on the I.
Oh, okay.
Maybe.
So I'm gonna put the +1 in front. Yeah.
Yeah. If you want to put the 1 in front, that's fine too.
Thank you, Oakspear, as well for pointing that out. Okay, so that's a bit more clear to write it for me.
Or you could parentheticalize the summation or whatever.
That's true. Yeah.
Does that make sense?
If we're counting arrows, though, we have 2 single arrows, though, don't we?
Right. Yeah. The first loop for n equals 1, right? We're going to multiply that by 2 to get the top right corner, which is 3. It's going to be 2 times 1 plus 1.
So oh, that's right. We do need to add 1 because we start at 1. If it started at 0, it would be fine with that.
If n is 0, then the summation is 0, so you have 1.
Right. Okay.
If n is 1, you get 3. N is 2, you get that 7. N is 3, you get the whatever it is on the top right, 13.
Yeah, top right is 13.
4, you get 21. And you're just toggling back and forth. The only reason I did 2n is just to center it on that bottom left corner. Because you're always, you know...
Just so, like get some consistency.
You know, I'm only stopping on the evens, basically, is what it was doing.
Yeah, it just made it harder for me to see that, like, it, and also had to do with the side length. Because I didn't get that when I first saw it.
So the 25, you finished your length 25 sides, which is going to be, because that's a top right corner, that means you've done the up and left. Up and right are both 25. Just like the first up and right is 1, right? Up 1, right 1. Now we're doing up 25, right 25, and we end up top right corner at 651. So the next move will be go down 26, left 26.
Okay.
Back to the other corner.
So, okay, now I'm trying to understand for myself where, okay, so our 24th side length, the second one ends at 601. So if we...
It's the length 24, yeah, the side of length 24.
Okay. Oh, so and so I see, so 626 is going to be in the upper left, because it's now side length 25.
And remember, we're not counting the, sorry, when I say side length, I'm talking about the number of arrows, not the number of numbers.
Oh.
Because we're already considering the previous number as being part of the previous side. So that bottom right corner is the end of the previous side. So how many arrows, how many numbers do we add on to move to the bottom left corner? We don't count that bottom right corner.
Yeah, so we have 25 up arrows, which is like adding 26?
No, it's adding 25, but the side there'll be 26 items on that side because you have to start with something.
Wait, we're starting at 601 and then we're adding 1 to it 25 times.
Correct. So we end up with 626 in the top right.
Okay.
Then we're going to add 25 more to get to the right side.
Okay, so I guess we have the answer, and I'm trying to figure out how I can. I think I feel comfortable explaining everything to this person, except for like we just got n equals 24 or 12 or whatever we had before, just by experimenting with Wolfram. We need to figure out a way to do that. Oh no!
So the summation of I is from 1 to n is n times n plus 1 over 2.
Right.
You're multiplying it by 2, so it becomes n times n plus 1.
Mm-hmm.
And then you add 1. Set it less than or equal to the number you're looking for.
Right.
Then solve for n. And you have
You
n is
can
going to be
irreducible
less than or
quadratic,
equal
don't
to.
you? Wait, we shouldn't though.
No.
N times n plus 1 plus 1 is n squared plus n plus 1.
Okay.
Oh, the 625, duh. Never mind. Yeah, you'll get. If you don't get this factor, it'll be a big problem. Okay.
So you could set it up as an inequality. It's like, what, or you could, you could plug in a number and see what you get. You'll find the pattern eventually. You're going to see, okay, that's how I kind of started with it. 1, 7, 13. Okay, it's not so much we're going up by a certain amount, but we're going up by like 1 plus 1 plus 2 plus 2. And then 3, 3, 4, 4, 5, 5, 6, 6. And so you figure, okay, so the first one you're going up by 2 times 1 plus 2, and then 2 times 3 plus 4, then 2 times 5 plus 6, then 2 times 7 plus 8. And then you could start to see, okay, there's the sequential pattern here. So let's do a summation, multiply it by 2, make sure we add the 1 in there so that because we're not starting at 0, we're starting at 1. And then you could continuously compute that bottom left corner, and you could actually just write out the numbers if you wanted to. As a chart, okay, you go start at 1, then you're going to add 2 1s and 2 2s. So that's going to be 2 times 3, 6. So that gives me 7. Then you're going to add 2 3s and 2 4s. That's 2 times 7. That gets me to, whatever the next number is, 13 or whatever it is.
Okay.
Or it's 2 times, 14. So it'd be 21, 7 to 21. And then, 5 5 6 6. That's 2 times 11. So you add 22 to that. And you could just chart it out, and it would take less than 5 minutes to get up to 24. I mean, you're doing it 24 times. And then you're like, okay, now I'm here. If I go up 25, I'm getting pretty close to my number. I probably don't need to go the whole loop anymore. And then you start plotting it out.
Okay. A nice job on it, I guess. That's a nice solution. I think it just works.
I mean, logically, it kind of works because you're looking at the number of increments you're doing per side.
Mm-hmm.
So.
In Oak Spirit, what to do if I'm entirely depending on my calculator and I have to go take a no calculator differential equations exam in a week. That's me got 4 times 5730 wrong. Oh no.
Don't feel bad. Don just got what was the number again?
46 plus 1 wrong.
46 plus 1 wrong.
Oh, that's gonna be terrible.
You're in good
Spirit.
company. You're in good company.
Yeah.
I can't count to 12, so
Yeah, Spirit. I hope that they wouldn't give you something that hard if you only have an hour, but it's just a hard one. Like, you gotta be good with the arithmetic, I guess. I don't have a good trick for you to use other than just practicing it a lot, and I know you already know that. So I'm sorry, Hope Spirit.
Double check your work. I mean, that's the best. 4 times 5730. Once you finish that, divide it by 4. See if you get back to 5730.
Jesus Christ.
That's how we used to do it back in the day before Wolfram and calculators and stuff. Write it out and then do the opposite operation to verify you got the right answer.
It's like, do you do 4 times 5730 on paper and get it wrong, or are you trying to mental math it? On paper? Oh, dang, that's rough.
Are you using Common Core multiplication, or are you doing it the old-fashioned?
I didn't know there was a new way.
Well, 4 times 5,000 is 20,000. 4 times 700 is 2,800. 4 times 30 is 120. Add those 3 together. Versus 4 times 0 is 0. 4 times 3 is 12. Put down the 2, carry the 1. 4 times 7 is 28. Carry plus the 1, 29. So you put 9, carry the 2. I think a lot of the Common Core like separates that into like, okay, you got 4 different problems: 4 times 5,000,
Oh,
4 times 700, 4 times 30, 4 times 0. You do all those, you add them together, and that's your answer.
that's how I do it mentally. But on paper,
Yeah,
I do it the old-fashioned way, I guess.
I do it the old-fashioned on paper. Yeah.
Yeah. Oh, I see Oak Spirit. Yeah, I'm not sure that like I'd say to take it slow, but you obviously don't have the time to take it slow. So it's just a tough situation there. NSPQ minus 12, 12, minus 12, 13. That means that one of them is in a corner, right? SPQ, so they do form a top left corner. Okay, awesome. So that means we agree. Okay.
Was the answer like, what's the shape of those 3 numbers, like Tetris
It's just
style?
like what's the arrangement of them? So I'm assuming a
What were
satisfactory
the
answer
numbers
would
again?
be 626 is an upper left corner with 625 below and 627 to the right.
Well, we found that 626 was the top left corner, right?
Yeah.
601 is in the bottom left, so 626 was the 25th number going up, so 626 in the top left. 625 is directly below it. 627 is to the right of it.
Yeah, I assume that that's our answer.
Yeah.
Oh wait, I wonder. I think they're provided possible answers below. I wish they included that in the screenshot.
Yeah, they never do.
Oh well. So they did post a second question too. I don't know if it looks even more geometric too.
That's not too bad. You draw the diagonal, and
Is it 4 times 730? Oh no, Spirit. Yeah, I'm not sure. Just it's something you have to like practice for, I guess. I don't know what else to tell you. The large square in the diagram is dissected into 4 smaller squares. The circle touches the right hand side of the square at its midpoint. Ooh. What is the side length of the large square? Wow.
I'm going to guess 20, but I could be wrong.
You know, I'm willing to just say that it's 20 so I don't have to do this problem.
I don't think that's right, but
Yeah, if it is drawn to scale, that is a pretty reasonable guess. They might be mean and not drawn to scale though.
I guess you could do something with angles, maybe? I don't even know.
I'm trying to think of something like if you connect like a right triangle where the right angles at like, you know, that intersection in the circle, and the other endpoints are at the end of 8 and the end of 6. You could attach that names to those unknown quantities inside the circle. I don't know if that gets you anywhere though.
So if you were to draw, oh, gee whiz.
There's a
I'm
similar
guessing similar.
triangle.
Yeah, I'm guessing similar triangles comes into play here.
Yeah. Uh, it's not really making use of the fact that it's a circle though.
I mean, do you have to figure in the center of the circle and then the right triangle formed from the center to the origin to the center of the big square up to the intersection, and then similarly with the and make that similar to the triangle formed on the left hand side of that center line? Is that the similar triangles?
I wasn't following what you were saying. I could actually go,
Yeah,
I guess, draw it on the board.
I don't know. That's a tricky one.
Yeah, this one, I might not be able to do this one, but I always try to draw those triangles and see what happens.
Oh, you know what? You might be able to shift the circle. Maybe no, you can't shift the circle. I was gonna say.
No, it's stuck at the right side.
Yeah, I was gonna say if you could recenter the circle so that it's centered on the center of the square, then you would basically take that 8 and you would cut it in half, right? Because you'd have 4 on one side, 4 on the other. But then what happens with the 6? Can you equally split that 3 on top, 3 on the bottom? But I don't know that you could do that.
I don't know either.
I know you could do the 4 and 4 because it makes sense. not bad. Did you just freehand that?
Yeah? Why?
We got to get you a pen on a string that
Well,
you could like draw perfect circles with.
that's a pretty good, like, I was thinking to myself, that's a
That's
pretty
not
good
bad.
circle, yeah.
That's not bad at all.
So the right triangles I was thinking are those two right there. I don't know if they really help you though.
I don't think that second one does. I think the first one might.
Like that first one?
The first one inside the circle, I
Okay.
think would work fine. But that second one, I don't think helps you at all
Okay.
because you don't. I don't because they're not going to be similar. Because the angles on the other outside one is 45 degrees, and the ones on the inside are definitely not 45. It's not nice.
Oh, you're probably right. Yeah, yeah.
I was thinking if there is something that's similar to it, might be if you take the intersection of the circle to the 6th length, and then draw to the right center edge, and then use the origin as your third point. Is that so? If you go down to this to the where the circle is tangent to the square.
Where from here?
Yes, that point. Sorry, delay.
No worries.
From there till the circle intersects at the length 6, and then down to the origin to the center of the square.
Okay.
Is that triangle? I don't know if that's triangle is actually. I can't prove that that's similar to the left one.
I doubt it.
Is there something you could do about figuring out that angle? Like trig wise?
I don't know.
Because if you, like I said, if you shifted the entire circle over 4 units to the left, then the center of your circle would be centered on the square, correct?
Right. But wait,
So
do we know 4?
Side.
Oh, yeah, you're
because
right.
the length,
It's 8. Okay.
The difference of the radius of the circle to the radius, or half the length of the square, is 8. So if you shift it over 4, you'll have 4 on each side of the circle. But then what does that do to the 6? It's going to compress it.
Yeah.
It's centered, so you know there's 6 at the bottom as well, right?
Yeah, not necessarily 6, but it'll be equal on top and bottom if you do shift it.
Well, right now it's 6 and 6 on the top and bottom, right?
Okay, yeah. Yeah.
So you do have an isosceles triangle there if you drew the other diagonal. I don't know if that helps you at all either. You know, the bottom point of the circle intersecting the central vertical line, and then draw that to that same point on the right.
Yeah, so like basically
triangle.
mirroring the second one, and it makes an isosceles. I don't. Yeah. I feel like that could be helpful if we could make some remark about how the 8 is related to that isosceles triangle that we could draw, but I don't think we can.
So, you know, if you draw that other diagonal in from the rightmost point to the bottom intersection of the circle with that midline.
Okay.
So, and then label the bottom part underneath the circle. Let's label that distance as 6 also, because it is centered. Correct?
Yeah, it's like vertically aligned.
Right. So the length of the square, the midline of the square, is 12 plus the base of that triangle, or the base of that isosceles triangle we just drew. All right.
Right.
And we know that that's equal to 8 plus the diameter of the circle.
8. Yes. Okay. Yeah.
So is there something we can do with knowing that the base, and having the base there? I mean, it's a chord, right? So we might be able to do some kind of chord mathematics.
Yeah, I mean, I feel like we're gonna need something involving inscribed triangles. or like chords. Hey Storm. The problem is right here. It's geometry.
We're trying to figure out the side length of the square.
Basically, yeah, of the big square.
Can we just say 8 plus the diameter of the circle and be done?
Well, you know it's bad when there's a geometry problem that even you don't want to do. Oh, you know, and it's multiple choice. I wonder if you can take the answers and somehow prove or disprove, or like at least like disprove the incorrect ones.
Let's see.
Like, can we do anything with 18 there? You don't want to start? No, I don't blame you, Storm. I'm about to just like give up on this one.
We don't know the angle of. We don't know that angle, so we can't use that to determine the angles of the triangle to figure out that side length. There's no way that the that chord that's perpendicular to their diameter forms.
The vertical one, yeah.
Yeah, no, that's not going to form an equilateral triangle because that wouldn't work.
Use a ruler, yeah.
It's not drawn to scale though, so that wouldn't
That's
help.
true. Yeah. Yeah. So this one looks like it kind of sucks. So I might just give the answer that you got for this other one and tell him good luck with the second one. Because this one at least was kind of fun, but the other one just looks like it sucks. So I don't know, unless you have the thought, Jet, I might leave you to it.
I have no idea.
Just make sure no one replied in the meantime. Okay, no one did.
There's no way to draw a right angle in that either, is there?
It's like you could immediately discard any answer that's not at least 16, right?
Yeah.
That's the best that I got, though, I think, for eliminating answers, though. I don't know if there's like a maximum that we can say, too. Okay, yeah. I'm going to start, like, typing out an answer, I guess.
Nobody's come up with an answer on that yet.
No, I just refreshed it a minute ago. Say my approach, even though it was your approach.
That's fine. You're writing it up.
Was to count the is to create a formula for the upper right / lower left corners by counting the arrows. Oh God. How do we explain this?
It's basically pattern detection, right? So we kind of look at, okay, we start at the center, then we go up one, right one, that puts us in a corner. Then we go down to left two, that puts us in a corner. Up three, right three, down four, left four. And so we note that we're doing the sum of, 1 to n twice to get to the next corner. right? Or to get from the
Okay.
center to the nth corner.
Right.
And then we have to add the 1 because we're starting at 0. And we're not starting at 0, we're starting at 1. So we have to make sure we include that central point. Once we figure out that pattern, then we can just plug into that, n times n plus 1 over 2 formula until we get to a corner, figure out which corner we're at, and then count from there.
Each number of arrows comes in a pair. It's twice, 2 happens twice, etc. Actually, so why is specifically the upper right and lower left corners? So we have to plug in, well, because of the way that it happens in pairs. That's why.
Yeah, because we're doing 2 lengths to get to the corner.
Yeah, so we could
It's
get
a
any
repeating
corner if we
pattern of 1,
remove
1,
the
2, 2, 3,
2.
3, 4, 4. So if you don't pair it, then you don't know, where you're at.
Right. Yeah, you have to do. You have to be a little bit fancier if you wanted to get a different corner. It wouldn't be that much harder, but yeah, we can keep it simple.
Well, it's just the fact that you can, if you see the pattern is doubling, right? 1, 1, 2, 2, 3, 3, then you can plug in the sum of I equals 1 to n and just 2 times it. And that's an easy formula you don't have to actually do much of addition. You can just plug in a number into the formula and get what you're looking for. I mean, the simpler way to do it is just figure out the pattern and then just evaluate, You're going to do 1, 1, 2, 2 to get to a corner, 3, 3, 4, 4 to get to a corner, 5, 5, 6, 6 to get to that corner. And then you realize, okay, you're adding 2 times 2 consecutive numbers, right? And so you're just constantly adding that up and you work your way there. If you wanted to go about it the brute force way, I wouldn't suggest that for numbers in the 2000 range, but
Yeah.
for 600, you get there pretty quick.
From 1 plus 1 arrows before that with 1 plus 1 plus 2 plus 2 arrows before it, and so on like that. We can create the summation from n equals 1. I guess we'll say I equals 1.
Don't forget that when you say the upper right corner is 3 with 1 plus 1 arrows, you have to make, that the 1 you have to put in there manually at the end of it.
Right.
Yeah. Because you have 1 plus 1 plus 2 plus 2 gives you 7, which is a little confusing.
I was trying to like get to the summation and then do that plus 1 thing.
Okay.
I guess I don't know if that's the best way to explain it. That's where I was
The
thinking.
first
at
corner
least.
is 3 with 1 plus 1 arrows before it, and since we started at 1, they become the number is 3 or something like that.
2, since it's pairs, and add 1 to whatever we get to get the number upper right / lower left corner. So our formula becomes 1 plus 2, I want capital sigma symbols. Equals 1 to n, where n is the number of arrows on that side. Or in that pair. where we plug in, say, n equals 2. Or, yeah, n equals 2. We get where the... Actually, wait, that doesn't make sense. N is the number of arrows in that pair, but... If we plug in n equals 2, we get... Oh, no, we get... Some... Oh, we get 7. There we go. That's why that... Okay, it makes sense. 7, the number at the end of the side lengths. 2.
Be careful again with the side lengths, because the bottom side is actually length 3, because you got that bottom corner that's already counted in the previous side. So the
Number of
side
arrows with 2.
that increased by 2 or something like that, or with 2 arrows. Yeah.
End of the
side with 2 arrows.
Side with 2 arrows. I guess sides with 2 arrows.
The end of the last side with 2 arrows.
Yeah, it's probably better.
Because there are 2 sides with 2 arrows.
Yeah. Even numbers for n will get a lower left corner. Odd numbers will get an upper right. We have a formula now and need to figure out where 625, 626, and 627 happen. Do you play Dopus? Oh, am I gonna get these nuts? I never heard of that. That's an actual game, and if that's a decent nuts joke, then well played.
It's an MMO.
Oh, okay. That sounds like a these nuts joke, right? Like Dopus.
No, that's a legit. It's a tactical MMO.
Oh, okay. I've just never heard of it, I guess. Yeah. With Gauss's summation, we know the sum from 1, or we know the sum of the first n numbers is 1/2 n plus 1. We can set up the equation 1 plus 2 is 1/2 n plus 1 is less than 625, and take the biggest value, then that works.
Or less equal.
Oh, fair. I can even do a fancy less than or equal to symbol.
Is that why you put that little command there?
Well, so other people can use it too, but it's also nice for me.
I think you should learn to write your responses in Greek.
Yeah. Probably be simpler. We said n equals 24. Yeah. N equals 24 as the biggest value. That works. Taking 24. So that's some Google Translate action.
That's just your first line.
Oh, okay.
For the first one, it was tricky.
It actually looks like it was tricky but fun. Like that second part looks kind of right.
I think that's the idea.
Yeah.
Although
Almost like
I
languages
think
are related.
the H in the looks more like an N for fun.
Yeah. I'm plugging it back into our formula.
So, when are you changing your name to this?
601 is in a lower. It does math. Oh my god, that'd be really funny. 24 is even. Oh my god, this is such an involved answer. I hope they don't ask a question because I'm. This is all I got.
The next side would be 25. Would go up 25 to get to the top left corner. So therefore, that would be 626, which is the middle of the 2 points you're looking for.
Starting
QED.
side with 25 arrows going up, and 601 plus 25 is 626. So 626 is in an upper left corner, with 625 just below it, and 627 just to the right.
Hey!
Okay. Yes, Dan, this is the Jed. Can you handle this much heat? Oh, I don't know. If the stream goes offline, I guess you know why. We're unstoppable. We work in it together. Yeah. Now after doing this whole explanation, and for the second one, no clue. Good luck. Keyboarding. It seems multiple choice. You may be able to somehow prove, or you may be able to somehow figure out what answers are incorrect. But I don't know how. Okay. All right. I guess I'm posting this. So they get for posting a competition math problem, I guess. Get a very long explanation in return. All right. Well, I guess thank you for your help with these problems.
Hey, always happy to hop on and chat.
Yeah. Well, I guess if there's another one like that, feel free to hop back on. But I'm gonna go back to looking around.
Yep. All right. I'll see you in chat.
See you. Okay. So yeah, that was Jed for anyone who jumped in late. Mic back up. Put it like there. Okay. Was offensive emo on all of Twitch? Honestly, I don't mind pineapple on pizza. It's not like the first thing that I go for, but like I don't mind it. Unfollows. What's happening here? Simplify expressions and generate equivalent expressions. I need help with all of it. Oh god. Oh jeez. Oh god. How many four pages? Okay. Let's see what this was. What's happening here, and if it's too involved, I'm just gonna not do anything. So actually, wanted to get. It only literally just got posted. Someone might swoop in on this one too. Okay, so oh, that's not. Ugh. Ugh. Okay, I hate zooming on this thing. Jed is always right. Oh, so if you say that pineapple pizza is bad, then it must be bad. I guess I can't argue. Oh, that rule. Dude, Yeah, I mean, I was thinking that we can, try to get them started. Like, not give them the answer, but tell them what the logic they should use is. So something like the expression 9 minus 2x minus 7 plus 4x. Was just an example up here? Oh gosh, this is a very involved way to show students how to do it. I mean, it's right. It's being rigorous as well. But I can just imagine being a student in 8th grade and seeing all my classmates' eyes and mine like glaze over, wondering why we need to do this justification crap. So I guess look at the first actual question. Eloise's math tutor used algebra tiles to model 3n plus 4 minus n plus 5. Oh. I mean, that's not a bad way to show how this stuff works, I guess. How do you say it simplified? Like, where do you enter your answer? Oh, wait, it's not a... I'm so used to things being on the internet. This is just like a worksheet, I guess. It's not like an online portal. This one being like highlighted black, though, is... Oh, because it's negative! Oh, wait. What is this? That's just a rhetorical question, and you don't actually answer this question, but you answer the questions down here? Oh, they asked the same question twice. Okay. I think that's how many n's you have. Yeah, it's basically how I think of it too. Like you have 3 n's, you have a negative 1 n, and you have a 4 and a 5. But I mean, I guess this gives you the template up here. Like if you rearrange things, you commute them. So that's all that's happened in number 1. And then write an expression, I mean, 3n minus 1 plus 5 plus 4. Write your expression from exercise 1 by grouping like terms. So that's the associate. So it's really like, they give you exactly... Oh no. Did I actually... I'm wrong? 3n minus 1n? No, you don't get to mark me wrong for not saying 1n. Oh. Did I say 3? Oh, okay. I was subtracting the coefficients already. I should have said 3n minus n if that's not what I said. Okay, so I mean, they really give the person the template up here, so... Let's see what the other questions are like. Actually, I think, someone else wants to comment on this yet. Distributive property. Dude, why can't you zoom in on this stupid website? Okay, fine. That's the best that we get. Can you use distributive property to expand expressions? Okay. It brings you to the same thing, I think, Jed. Yeah. The Baines' house is a deck next to the living room. Now, I'm pretty sure it's spelled different, but I choose to imagine this is the Bane from The Dark Knight Rises. And I'm imagining him just like, having retired from being a villain and building a deck by his living room, I guess. What is the combined total area of the living room and deck? The deck and living room combined to form a rectangle. What is the rectangle's width? Well, which one is width? Which one is length? I guess they want 12 as the answer for number 1, because number 2 says write an expression to represent the combined length of the rectangle. So number 1 is 12, number 2 is 14 plus d. And then they're going to want you to distribute that 12 inside. Okay. Amber's saving money to buy a bicycle. She saved $60 her grandfather gave her and plans to save an initial $5 each week. Okay, so we're getting into rates. Or like, lines. How much will Amber save after W weeks? Is law degree? Is Reggie... I don't know what reference you're making, Jed. To be able to... Oh, complete the bar diagram. I get it. Okay. I thought it'd be like some TV show involving a lawyer named Reggie or something. Dude, I gotta use the bathroom so bad right now. It's always like I use the bathroom right before I start streaming, and then I always have to use the bathroom on stream. I'm gonna take a quick break. Sorry about this, people. Okay, we're back. So thinking about this person, they just kind of posted a whole bunch of worksheets at once, and just saying that they're generally confused. Let's just only answer. Why is 5-1 harder than 5-4 and 5-3? What's 5-2? That's kind of the same. I don't know what's up with that, but let's just get them started on the first like two that they posted. Pages are also commutative, yeah. Yeah, this is my mistake. That's not 5-3, that's 5-3, so this is page 2, of course. Or not tableau, the example at the top. Presented a little differently. So for number one, number one, when you rearrange terms, you're using the commutative property. They want you to group the ends with the ends and everything without an n together. Well, I shouldn't say group. You should put. They want you to put the ends with the ends and everything without an n together. Grouping terms like in number two, it's the associative property. You to make parentheses around your groups. For number three, to follow through, actually adding / subtracting things. This I was gonna add in a caveat about, like, it's not always gonna be this annoying to do grouping terms like that. They're just trying to teach you it in a rigorous way, and then you don't have to show it again. But I'm not gonna do that. And if they want to get back to me and ask a further question, then I'll let them know about the other things that they posted. But let's just see how they react to that. Just an automod response. It's 0.531. Oh God. The shadow. Shadow of the phone losses. I don't know what's happening with it. Is it ln 2x equals 4? The only part that was in the shadow is the only part that's relevant here. And ln x minus 3 equals 2? I don't know what any of this other stuff is. Oh, wait, maybe that's the work. Wait, or are they talking about this x? Wait. I don't know. Which ones are they asking about, dude? Wait, okay. Am I... Why? These images are different. I still don't really follow their work. But Reddit is also being weird. Like, that equals 8 is cut off. Like, the original image has 12e to the something x minus 2 equals 8. I'm going to move on because I don't know what's happening. But sorry to that person, I guess. This one, let's verify it. Chart the simplified forms of the expression secant squared sine 2 theta. So they wanted to use identity, at least for one of these, the 2 tangent one, they wanted to say that sine 2 theta is 2 sine theta cosine theta, which is where that 2 in front comes from. Secant is 1 over cosine, so the cosine and the cosine cancel, and you end up with sine over cosine, which is just tangent. So I agree with that one. If it's tangent, it's not going to be cotangent. You don't have tangent squared, so it shouldn't be a secant squared. Same with that one. But yeah, I agree with this person that the other one is also good. So I don't have anything to add here. Plot a line of best fit manually? That sounds terrible. Why would they make you do that? I mean, I guess if they don't expect it to be that accurate, then it's okay. Desmos does regression? I didn't know that. How did, like, there's so many hidden features they just don't tell you about. I feel like maybe I should bother to actually Google it, but above 998? Really? Like, why? That's really freaking accurate already. I don't have anything to tell this person, I don't think. That's about a thousandth of a decimal in there R squared. That's... I don't have a good thing for them to improve on. Oh, this person is just begging me to shill Paul's online notes. This is like the perfect person to look at Paul's online notes. Okay. Yeah, no, after reading the body of their posts, that like that this is exactly what they're looking for, I think. Okay. Ugh. All right, so I think unless something new just got posted over here, we don't have. Oh, okay. I spoke too soon. Oh God. I was about to say that we should just go to some study problems or something to fill in time, but let's look at this problem, and if we don't want to do this, then we'll find something to study. I don't really know what. Input-output matrix for a simplified economy with just 4 sectors. Suppose the demand in millions of dollars matrix is matrix D, given that's like, okay, the little vector that's over here. Find the amount each sector should produce. I have no idea what that 4x4 matrix means, but if the question is to just do matrix multiplication, then we can do that. Input output matrix with demand. Demand? Demand. Ah, of course, Leontief models. 20, oh yeah, what does it mean? Like 20% of the tailor's production is used by the carpenter? Wait, A23. Wait, 2-3? Shouldn't be 3, wait. Row 2, column 3. So are the columns input in the rows? That seems backwards. The farmer himself consumes 40% of the food he produces, gives 40% to the carpenter, 20%. Okay. Produced, used. Fair enough. I think this part is actually important to doing the problem, because I assume it's just going to be multiplication. How much should each get paid for his efforts? Well, that's... Depends who you ask, I think. Interesting. Hey, Yanis. Sure. If I could do it. Oh, you're solving this system. So you're not multiplying. How do you solve that? I guess they're explaining it. You subtract the x over, so you do I minus ax equals b. Then you left multiply by... Oh my god, that's so tedious. I hope they're allowed to use calculators. Alright, but let's look at Yanis's first. Let a sub n be a real sequence with a sub n not equal to 0. And the absolute value of 2 a sub n plus 1 over a sub n is less than or equal to 1 for all n show that an approaches 0. Isn't that just the ratio test? Do we have to prove the ratio test, or just are we like? Because you have the limit of the terms. You have the limit of the ratio being less than 1 there if you were to divide each side by 2. Oh, that's for series, isn't it? Though you're talking about a sequence. Okay, I think I have part of an idea. I don't know how good of a proof this is, but I think the idea is that you show that's a decreasing sequence, and if it never equals 0, it means it must level off and get close to 0, and that's your limit. So, ah. 2 a sub n plus 1 over n sub a. That's what I was about to write there. that'd be quite the sequence. Dude, what? I can't write. Something equal to 1. For all n, show a sub n approaches 0. Okay. Yeah, the ratio test, as I learned it in the calculus class, does not apply because that's only for series. I think the same idea does apply to sequences, but it's not stated that way that I've seen it. Because, and I imagine I don't think it's that bad. Like, I always put the idea on the board here. I don't know if there's a way to show it better than what I'm thinking, but like, I would start with this given statement and say that by properties of absolute values, you could say this is, you can bring the 2 outside. An absolute value of 2 is just 2, and let's divide by that 2. Actually, by the same property of absolute values, we can split up these things too. And then multiply a sub n over. So you have for all n that a sub n plus 1 is less than a half of a sub n. So not only is it decreasing, it's decreasing pretty quick. Like the term is getting at least halved each time is what this means, if not more. And if it can never equal 0, well, yes, it's getting halved. I'm thinking about the absolute values if that makes it trickier, but no. A sub n is decreasing. Well, Alp's absolute value of a sub n is decreasing, since a sub n plus 1 is less than or equal to 1/2 a sub n for all n. Sum n equals 1 to infinity of a sub n converges by ratio test. There's also a theorem if series converges. Oh, really? You cannot prove it doesn't go to 1. The very easy argument you see on the board. Oh, really? Underscore? See, now, I don't have the complete argument, which is why you might not see it on the board. I mean, it can't be 1 because all you're given is that you're not equal to 0. So if you're decreasing, you're forced to go past 1. I don't know how you say that rigorously, though. So a sub n is either positive in decreasing, or negative. No, what am I spelling? Yeah, so okay, yeah, the limit, it can't be 1 or any other number because it would violate this decreasing or increasing kind of thing that we've concluded, or at least that I've concluded on the board here. Because our only restriction is not equal to 0, so we can't just stop at 1, I don't think. It's always a question of how much justification you need, I guess. That's where I'm getting some hesitancy from. Is it positive increasing or negative? Positive and decreasing, or negative and increasing? I mean, can you skip over? Does this exclude the possibility that you skip over 0? Like, oh, maybe that's what you're saying, Yanis, with it like not being 1. Like, what if it just never hits exactly 0, but it does shift from positive to negative? Is that the concern? Induction, I think you need a specific sequence to do anything with induction. This is a generic sequence, A sub n. I'm not sure, though. You might still be right. Folk Spirit, I don't see how you apply it, though. Well, one plus 1 over n is decreasing and strictly positive. Oh. Yeah. Because, so do you know this is true already? Because if you know it's true, I think the key must be that 1/2 then. Like that 1/2 is very like aggressive, I guess, in how much you're decreasing. Because otherwise, I think you just gave a counterexample to show that, well, you don't know if it necessarily follows that. Okay, you raise a good point, Yanis. So right, 1 plus 1 over n is decreasing. So it's not enough to say the decreasing series must go to 0. I would assume that if we know this thing is true, that the key is that 2, or I arrange it to get to be 1/2. So how would 1 plus 1 over n not follow this? I feel like if you're having to have it, could you say that? I'm thinking specifically about 1 plus 1 over n here. At some point, you're going to be like, is equal to 1 plus, let's just say, epsilon for some epsilon. Like, you'll be just a little bit above 1. Or for some n. Or for some n. Some epsilon greater than 0. And then, so the next term, n plus 1 is going to be equal to, or n plus 1 is a sub n plus 1 is less than or equal to 1/2 times 1 plus epsilon. And that is going to be less than 1, is my argument, if epsilon is very small. And it must be something like that. Like, you can't approach a non-zero number because of that 1/2, I think. I don't know if you... I can't exclude this possible case where you just skip over 0. That one has me completely stumped. But I think this sort of argument would work for everything that's not like that. Because I don't think this implies that a sub n is always greater than or less than 0. It's not necessarily bounded. It's just not equal to 0. Or something bounded by 0. I don't know. Is there a way to exclude a sequence like that? It's kind of an interesting question. I'm trying, like, if you had... Like, we need to show that this somehow implies being bounded by 0. Or could it be alternating? It could be... an alternating series would probably fit the bill here, too. Oh! Yes, you can't have this. Because these terms have to start decreasing. Like, even if you do cross over 0 without actually hitting 0, now that you're in the positive realm, the next point has to be down towards 0. Okay. This isn't a rigorous argument, but if you do have a series that just skips over 0, your next one either has to be like down closer to 0 or like back over past it. And either way, you're getting closer to 0, I think. So maybe we should look at a proof of the ratio test if it does involve this, because that might help address both of these questions. I think I figured out the idea, although I have a hard time writing it in formal language. Where we don't necessarily have to even explicitly address this case. We do have to explicitly address that on the left side. So I guess if I were to continue the formal language, formal-ish. Positive and decreasing, negative and increasing, or alternating. So I think in each of these 3 cases, or maybe you do have to address that. I think you break it into 3 cases there and show why it must approach 0. And I think that's possible. I don't know. Let me go check on chat, and I think at this point it'd be a good spot to do the Googling. So yeah, underscore, I think I did do that. That's my thing on the left side. I mean, I didn't write it formally, but like I basically do the argument I did on the left side, where because of that 1/2, is my cam gonna block it? Oh, it kind of blocks it. That 1/2 having to be at most a half of the previous term forces you past one or any, I guess, whole number, or you're basically you're getting into fraction territory between 0 and 1, because decreasing by half each time just forces you. Oh, sorry, that's actually kind of the argument that we're making. We're just not going full-blown induction. So I think I have the right idea. I'm just taking it more as obvious, or an exercise for the reader, I guess. I think you have the right idea. We just don't need induction specifically to, I think, do what you're thinking, if I'm interpreting you right. So yeah, Yanis, I don't know if you have any thoughts on what I've said. I can try to write out what I said a bit more formally too, but I just kind of was taking a pause here to see if you had a question, or I guess if you're understanding where kind of what I'm doing with this so far. You want to structure it as a sub n doing contradiction with assuming a purchasing that's not 0. I think by my logic, proof by contradiction isn't necessary, but you could do a proof by contradiction and use the same logic. Actually, I don't know if it's even accurate to say the 3 cases that I said at the very end of my proof here. Or not even proof, but, start of a proof. No, maybe it's okay. I'm trying to think of that exactly how you would make that argument that I'm saying more formal. I'm just gonna kind of do it off to the side because I don't know how it would fit in with this proof. Assume a sub n approaches C for some C not equal to 0. So, I mean, I think what we would do is take, like, I'm having a hard time doing it generically, but I want to take, like, should I use some epsilon neighborhood around C and show that 1/2 is going to get us outside of that? Like, since A sub n converges, should we, no, do we want to say a generic epsilon, or do we want to say like an epsilon like 0.1 or something that's less than 1/2? I think we want to say like 0.1 or anything less than 1/2, really. Such that A sub n is within C plus 0.1, oh, C minus 0.1, comma C plus 0.1 for all n greater than or equal to n. Now, by this thing that we found over here, let's actually write that in blue. Oh, is this particular to 0 though? I wonder if I'm not doing. I might be making a logic error here where like this kind of argument doesn't really involve 0 at all, does it? I'm not sure how we're going to address that part yet, but it must be that A sub n plus 1 is less than 1/2 A sub n. And I basically want like one more sentence saying how this 1/2 shoves us outside of this neighborhood. You think that's something that's like somewhat like what you wanted? All right. Oh yeah, underscore. I think we're taking convergence as a given, and like it's for the sake of this little like side tangent. I don't think we've proven convergence in general, though. You're right. Have we? I mean, we know it's deep, or we know the terms. This is Cauchy. Sorry, it's a really weird way of saying it. Is it Cauchy and it must converge? I'm not sure. I don't know how you prove convergence in general for like the general problem statement, but at least for a little aside in red, I wasn't worrying about divergence. A sub n is less than or equal to 1/2 to the n A sub 0, Zone Ranger says. Also, hi, Zone Ranger. A sub n is less than or equal to 1/2 to the n a sub 0. Oh. And that's just a geometric I guess sequence. It would approach a sub 0, though. So, okay, yeah, maybe... Does it have to approach 0 then? Or no, if you repeatedly have a number... Are you approaching... No, you are approaching 0, right? If you repeatedly have a number, you're not approaching a sub 0, you're approaching 0. Okay, this is a fun question, but I'm like... Oh, I'm sorry, Richard. I saw your message, but I got distracted with others. A sub n plus 1 is half a sub n for all n, so 2 times something like that, Richard. It's an inequality rather than equal, but like you take that as your worst case. Take epsilon equal to 1/3 absolute value of c. Let me just... Oh, that might be a cleaner way of doing it. That relies more on the actual epsilon delta definition. And I think that's basically the idea that I was trying to go for, just written better. Also, I feel the urge that, like, huge shout out to Zach for me being able to even slightly talk about this kind of intelligently. Without that real analysis class, I definitely would not even know how to start this one. I mean, I probably could have done the inequality thing that I did on the right in blue, but I think it's as far as I would have gone. Ranger gave it away raw. I mean, with this, I definitely don't mind. This is like spoilers almost. Oh no, this wouldn't imply Cauchy because Cauchy is any pair, not just consecutive. Yeah, I don't know how you prove convergence. It is bounded by 1/2 to the n a0. Or like that term. Application of the squeeze theorem. I was worried about the to the n part, I guess. But oh yeah, squeeze theorem. That does just that does do exactly what you want, doesn't it? Huh. Well, I guess. Okay, yeah. I think it's just squeeze theorem. So I'll actually like write on the board for those who are interested, but okay, that's so much easier than like the stuff that I was trying. Okay, it's like I completely missed that. That's you can just squeeze theorem that. I did not squeeze theorem in my head at all. So I think the idea is this statement gives you a clue about how you can do squeeze theorem, which is basically that a sub n is less than or equal to 1/2 to the n a sub 0. Do we need the absolute values on a sub n, or can we just? Yeah, we do. Yeah, I guess. Okay, the absolute value on the a sub n is throwing me off, but like in the middle there, if it's absolutely convergent, it must generally be convergent, but not the other way around. I hope it's true. I don't know though, but it's kind of weird to bound it below with a negative number, like an absolute value that's always positive. But if you do the limit as n goes to infinity, that goes to 0, that goes to 0. Well, I should do limit. I'm still, I forget the direction that the implications go with absolute convergence, I guess, but it's something like that, right? Oh, shoot, I'm not, I forgot to bring the cam down. Let me show the whiteboard. Because the argument is the same. Okay. Like, all right, I guess they use that same argument proof for ratio theorem, ratio test. Let me sequence absolute convergence. It's gonna be curious. I'm gonna bring the cam back up in a second. I mean, I'll just look at it for a series and assume that a sequence is the same. It's good enough for me, at least. So a sub n converging does not necessarily imply the absolute value convert. Oh, okay, cool. Yeah, that's what I wanted. Okay. So, I mean, this is for series, but I would assume the sequence is the same. Hey, Ben. Okay. See the more elementary approach? Oh. I got kind of stuck with the elementary approach. I think there's a path there, but I can't find the exact one. In the basement also, I was doing these simple questions without using a pre-made rule. I mean, what if you have the squeeze theorem? Richard Cuttingware. a sub n over 2 over... Oh. I have a hard time getting to the conclusion on that statement, or like understanding it. Squeeze theorem is pre-university in France. I mean, so I only learned squeeze theory, I guess, in a calculus class in 12th grade in regards to series. I don't think we were even taught it with limits. Or like, just like the squeeze theorem also works just like for limits in general, right? I don't think they taught us that. We definitely didn't do anything with sequences. Did we ever learn the squeeze theorem just for sequences in specific? I don't think I did, to be honest. It makes sense, and I know that it works, but... yeah, I don't know. Oh, I thought the index was n over 2, but it's a sub n and then all over 2, not a sub and n over 2. And then the a sub n's would cancel. Just getting back where you started. Or I guess maybe you just really don't want to cancel the a sub n's because then you haven't made any progress. Oh. I'm not sure, but yeah, and it's at least in regards to like doing the elementary way. I think I've given you all that I can figure out easily with what I had written before on the board. It would take me a lot of thinking to actually work things out, I guess. A lot of ing and umming. It seems possible, it's just kind of a lot. I wonder if, like, is this a problem that's, like, commonly done? Just want to see what comes up if I try to Google it. No zone, just the sequence. That it specifically approaches 0 is what Yanis was asking. So I can bring up the actual message again. Here, I found it. That was the original question. You got what you wanted to? Okay. I'm glad to hear that, but if anyone else has like more thoughts... Why does my hair look so weird right there? Sorry. If anyone else has more thoughts, feel free to like... in your head does in fact use what you gave to show the sum also converges. Oh. Yeah, I mean, I think Enos was looking for, I guess, like not squeeze theorem, but squeeze theorem is just the easy way. So I definitely like your way more. It seems like there's something you can do without squeeze theorem, but it's going to take a lot of writing. But thank you for the help. Actually, I should give out some saves, right? Zone Ranger. Yanis for the good question. Oh, is Enigmabot gonna be asleep? Oh, I did at saves. That's not good. And then underscore. The definition of a limit. You mean it definitely seems to be involved at least in some way. Definition of a limit. Richard was in here discussing it. Oh, and then Oak Spirit as well. Okay, so I'm trying to make sure I'm not missing anyone. Sorry to like flood the chat with these. Okay. Asaben. That geometric series, wouldn't it approach 2 a sub 0? Oh. I guess I'm crazy. Some 1/2 to the n. Wait. It's the first term over 1 minus the rate. That's what I was thinking it'd be 2 a sub 0. I guess I'm not actually 2 if you start at 0. Oh, okay. I guess you can just take the sum from n equals 1 then to avoid that. That's interesting. Yeah, I wouldn't think it'd be as easy as just like summing each side, but it works out because the geometric series are so nice. By monotone convergence, some a sub n converges. Okay. I get it. Let's sum up. A sub n plus 1 is less than a half a sub n for all n. So a sub n is less than or equal to a half a sub n. Yeah, sure. To get the idea for the induction, the formula I gave you earlier. Okay. I'm on board with that. Because yeah, you can always express, you know, your n plus 1th term or whatever as increasing powers of a half times some other term before it. It's a fun problem. Oh shoot! You know what, Zone? A long time ago when Zach's class like first started, you told me about a video. I don't remember if it was on this exact sequence, maybe not with those like preconditions. From someone Penn. I forget his first name, but I finally went back and watched it because I forgot to do it at the time, and it was really good. Working with this recursive sequence, it turned out to be super crazy. Yeah, the question was just for like generic starting points. Other than that, I think it was the same thing. We always take the average. Yeah. Okay. Oh, that's right. Before this all started, I was looking at this. input-output matrix stuff. But someone else got to the same answer that I did, so I don't have anything to add here. But yeah, I don't see any other questions, I guess, from chat or in my Discord, so I'm just going to go back to looking for questions kind of randomly on the internet for now. I do have a DM, though. Let's see what this is. This person was asking for some kind of resource to learn calculus from without too many proofs. I get a random GIF or GIF or whatever. You know what? I appreciate it. Oh, thanks, Dan. Michael Penn, that was his name, yeah. That dude is super good at explaining things. And it was interesting to see like how much depth that that sequence has. Yeah, even like 603. I had a couple of people follow while I was offline over the last few days, so thanks everyone who's been here. One half to the n, absolute value of 0, which is to 0. Ooh, and I'm trying to understand that because it looks like it'd be helpful for me to like know that. That every term individually is less than epsilon. Isn't that presupposing that... Oh, we already know that converges to 0. That's right, so that's why we're allowed to do that. Okay. Fair enough. So I see that accent over the E in definition. European exposed. Even though you said that you made a reference to like school in France before, so I assume that you're French. French, yeah. My teacher assigned the take-home tests, which we were able to use notes. Oh, okay, so they're... Okay, I really appreciate this disclaimer from the person saying that they're not trying to cheat. I mean, of course, we have to take them at their word, but I'm willing to do that. 5D is what they're struggling with. So it looks like we got some polar curves, which are always fun. I don't know. That's as zoomed in as I can easily make it. It's not going to look good, but at least on the stream, I could crop it and blow it up a bit. It's probably going to look terrible, but I feel like it's not very readable how it is right now. Okay, hopefully that's possible to read. I can see it okay on my end, but I don't know how it looks on stream. A graphing calculator may be used in this question. Let S be the region bounded by the graph of the polar curve. R of theta equals 3 root theta sine of theta squared. I'm glad they let you use a graphing calculator. For 0 is less than or equal to theta, less than or equal to root pi, as shown in the following figure. Okay, just like a lopsided flower petal. Find the area of S, so you do your... Yeah, it's 1/2 integral of r squared. And then your bounds. Okay. I agree. They're asking about D, but I'll just look through their answers for A through C. Make sure that we agree. For B, I've never seen like the average value done for polar function. That I think that's how you would do it, though. I don't have an issue with that. There is a for C. There's a line through the origin with positive. Hey, Gold, polar coordinates, your beloved. I love these things too. What spicy food we? Oh my god! I made this orange salsa. Girls love limicons. Yeah, I made an orange salsa. It was my first time. I was using chilies de arbol, and I didn't know, but they're super spicy. And I put a bunch of them in because the recipe said to put a bunch of them in. Arbol chilies, yeah. And it tastes really good, but it's so spicy that like I was getting the hiccups and like it just wasn't good. Hope you wore gloves. I actually didn't. I turned out okay though. I if it's like a dried chili, is it the same thing with having to wear gloves? I don't know. I didn't particularly touch my eyes, I guess. So maybe I just got lucky. Hey, Bio, are having some hoes over? You know, not right now on stream, but you know, in general, I have, you know, a line of hoes coming in and out. And spades and shovels. Gardening expert, yep. I teach them. Find through the origin with a positive slope n. Integration of natural logs. Alright, that's clever. You know, that's a save. Oh. So, okay, well, so this person's work, I agree with A and B. They're asking about D, but I still want to check their work for C as well, I guess. There's a line through the origin with positive slope m that divides region S into two regions with equal areas, right? But do not solve an equation involving one or more of the integrals. The solution gives the value of m. This seems reasonable. Yeah, I guess I agree with this person's work for C as well. So let's move on to D. For k greater than 0, let A of k be the area of the portion of the region S that is also inside the circle r equals k cosine theta. Find the limit as k approaches infinity. Oh. Ooh. The area of the portion of the region S, which is our original function. I assume it would... So a circle with r equals k cosine theta is always like on the right side of the origin here as they've drawn it, and you make the circle arbitrarily large, I would expect you to approach like the quadrant 1 portion of this area from 0 to pi over 2. Does Desmos do polar? I want to actually see this in action. Because this would be like a perfect thing to do with Desmos as well. So if we have r equals k cosine theta, does Desmos know what to do with that? It does. Yeah. Okay, okay. And then we also have r equals something. 3 root theta. 3 square root theta. Ooh. I guess I've seen that before with what square root of theta is like. Sine of theta square. Oh my god! Calm down, Desmos. This is like it's like a cartoon. The Blam like punching thing in the old like Batman cartoons. That's what this reminds me of. We need to restrict our theta here. We're going to square root pi. Going to light speed, yeah, exactly. Okay, it's more like it. Okay, and so k, let's vary k between 0 and 10,000. Sure. Oh, okay, maybe 10,000 is a bit much. 1,000. Okay, so yeah, like, I mean, even then. Yeah, okay, you know what? 500. You don't need a very big value of k to demonstrate this, I guess. Yeah, the circle's gonna like flatten out and flatten out and flatten out and get really close to being a vertical line that just captures the entire area here. So they want you to like, that's my intuitive feel for what this limit should be, I guess. How do we actually show that? Oh, actually, okay, that's a nice zoom. I should have done that a long time ago. So I'd love to just evaluate the integral from 0 to pi over 2 and call it good. I don't know if that's good enough, though. So, I mean, I guess I like their setup here, as long as they mean, like, you know, one of these r's is k cosine theta, and the other r is the original thing up here. So our lower bound is definitely, for any k greater than 0, the lower bound is certainly going to be 0. Oh. No. Wait. Cosine of... Where does the circle actually stick? Cosine of 0 is 1. Make it a unit circle here. So cosine of 0 is 1, so the circle starts out here for theta equals 0. Okay, that's important to know, I guess. So they're going... This is a weird integral to set up, because the green curve wants to start from 0. The circle wants to start from over here. So how do we set up this integral? If we're squaring them, do we not have to worry about, like, bound flipping? And so it's okay if our bounds are backwards for one of them? Okay, just as a sanity check, if I do the integral from 0 to pi of cosine theta, is that it going to be half a circle? Because maybe we don't need to, if we set up our outer and our inner correctly, maybe I'm worrying for nothing here. Oh my god. Let me X out that tab. Thank you. Okay. So 0 to pi. Well, I guess we want 1/2 cosine squared theta. No, Wolfram. That's not what I want you to do, Wolfram. There, okay. This math input thing really likes when you put the multiplication signs in explicitly. When it's misbehaved, it's usually because I got lazy and didn't do that. Cosine squared. Why is that pi over 4? Wait. The area of a circle is pi over squared. Okay, let me. I need Paul, I guess. Hey, Central. You know, you're so good at getting first. It's crazy. You always finish first. There you go. It's the spirit. Oh, it's because zero to pi is the entire circle? That still makes no sense. I should be getting just pi, not pi over 4. Oh wait, it's diameter 1. Radius 1/2. That's okay, I get it now. Okay, so then pi over 2. Pi day is gone. Oh, you're right, my bad. We're not allowed to use pi anymore. Yeah. We only get to use it 1 day a year. Okay. This stream is now Don relearns polar coordinates, I guess. Okay, so the upper half of the circle goes from 0 to pi over 2. It was alright, yeah. I didn't roll out the crust quite evenly, and then like the filling, I feel I could have used some spices and a bit more salt, but overall it was pretty good. The gas pastry. So can we treat this green curve as our no? Yes? If we get the bounds right, we can treat the green curve as the outer. How do we get the bounds right? we do two separate integrals? One between 0 and this intersection point with the green curve. I think that's the key. And then another from this intersection point over to the origin with the circle. I can't think of a way that you can do this with one integral here. I feel like that's what they want you to do, though. But yeah, I think I'm getting confused because, like, these aren't on the same phase, I guess. One is sine and one is cosine, and that makes things a little hard. Can we, if we equate the two, oh, you can't really solve that algebraically. So what would I want to say to this person? Yeah, one integral involving the circle going from, or sorry, involving the, I said the original function from, I need theta, symbols, theta equals 0 to the intersection point, and another integral from theta equals intersection point to another integral involving the circle I said that was pi over 2? No. Yes, pi over 2. What I'd say instead is to look at the problem intuitively. As k gets very large, r equals k cosine theta becomes a larger and larger circle in the portion in the portion next to our original function becomes more and more like a vertical line like theta equals pi over 2. So I would think that the limit as k approaches infinity will be the same as the original function, or it will be the same as the area of the original function from 0 to pi over 2. Not sure if that's the intended solution, but it makes sense to my eyes and is possible to calculate. I guess it makes sense to me. I don't know why I'm being weird with my phrasing. Yeah, that's kind of a fun question. I wish I had a better explanation. Like, I feel like there should be some kind of way to do it with an integral that actually involves the circle, but I guess if you don't have to do that, then why should you? Something that at least helps the person a bit. Yeah. It's been half an hour, no one else replied, so. I just gave him something. Zoom member came across a question which I don't know how to do. 57 inch from the base of the building. Oh, we got Trig. They use 55 inches? Like, I assume they mean degrees there. This is geometry that I know how to do, which I'm thankful for. Because we just need, it's just tangent. an angle of 55 degrees. I'm going to fix that in my answer. An adjacent side length of 57 inches. And want to find the opposite side length. Height of the building. Since tangent is opposite over adjacent, by SOHCAHTOA, we should use that. Tangent of an angle is equal to opposite over adjacent. Plugging things in, we get tan 55 degrees is equal to opposite over 57 inches. Multiply each side by 57 inches to get 57 inches times, I'm going to use x for times, because I assume it's more familiar to them if they're in a geometry class, is equal to opposite. Now plug it into a calculator to get tangent 55. Make sure we're in degrees. Oh, hey, Wolfmouth even knew. 81.4. It's weird to measure this in inches. That's not a very high building at all. It's not even one story, I don't think. But, you know, we don't have to worry about, I'm not going to worry about the units, I guess. Is that a reasonable answer? 81, I mean, aside from the real world implication of an 81-inch tall building. If this is in feet, you know, it's definitely reasonable. Yeah, if you're sitting 55 inches away, you're not sitting very far away at all. Yeah, the units are weird. I'm just gonna. It might have been in feet, and they just put that because they also messed that part up. So I'm not gonna worry about the units too much here, I guess. The inverse of that function? I don't think that has an inverse. Oh, they want a numerical approximation for the inverse. I don't know that either. I would guess you just calculate values for the function, switch the coordinates, and then look for some kind of regression, but I assume that they would know to do that much at least, so they're probably asking for something more advanced. Hmm. Okay, that one has an answer. Hmm. I am kind of running out of questions here. I might be sneaky and switch over to video games. Because now that the real analysis class is over, I have a bit more like energy to do other things, I guess. I do kind of want to finish that Pikmin playthrough at Sark. It's not a very long game, so I feel like I've only played like once or twice more to actually beat it. But yeah, I think I will switch over to Pikmin. If you want to watch math, you should head over to Dr. Gold's channel. Looks like he just went live. But yeah, I think I'm gonna wrap things up for math right here today. If you're still in math, I recommend you head over there. I'm gonna cut the YouTube stream off here, so if you're here on YouTube, I appreciate you. I'll be back on YouTube on Thursday. Yeah.